Hi everyone, today we're going to practice finding the equation of a line from both the story and from tables of values. We'll begin with finding the equations from some stories. In example 1, it tells us that a banquet hall charges a flat fee of $300 plus $20 per person. In order to create our equation, we're going to need to know both the rate of change and the initial value. In a story, we can look for the word per to help us determine the rate of change. We know that the number that will come before the word per, or for each, or for every, is going to be the rate of change. So in this case, we have $20 per person as our rate of change. Our initial value will likely be the other number within the story, but we can also find hints within the story about the initial value. In this case, it talks about the banquet charging a flat rate. A flat rate or a flat fee is a really good indication that that's going to be the initial value. So we have an initial value of 300. The next thing we need to do is find out what we're going to use for both our independent and our dependent variables. Again, that word per around the rate of change is going to help us with this. We know that when we describe a rate of change, we describe it as the dependent value per the independent value. So the word that follows per is going to be your independent variable. In this case, after per comes person. So our independent variable is going to be P for the number of people. The dependent variable will come before the word per. In this case, it's talking about money. So we're looking at the charges of the banquet hall. So we can use C for charges. Now we can create our equation, remembering that our equation is going to be in the form dependent variable equals rate of change times independent variable plus initial value. Our equation will be C for dependent variable equals 20 for the rate of change times P for the number of people plus 300 for the initial value. In example 2, the story tells us that Lindsay earns $10 per hour. Again, that word per will give us a hint about the rate of change. We know that the rate of change will be $10 per hour. The initial value, on the other hand, does not occur within this story. There's only one number provided, and we know that it's the rate of change. This means that this must be a direct variation with an initial value of 0. We then can move on to finding out what the independent and the dependent variables will be. Remember that it is going to be the dependent variable per the independent variable. So after per comes hours, and this is the independent variable. So we'll use H for hours for the independent variable, and the dependent variable can be E for earnings because that's what we're trying to calculate overall. Our equation then will be E equals 10H. When we're trying to find the equation from a table, we're going to need to calculate the first differences. And we'll do this on both sides of our table. On our right side of the table, or the dependent side, or the up and down side, we can find the rise. And we can see that each value is increasing by 2, so our rise will be 2. On the independent side, or the left side of your table, we can find the independent variable, or the run. So in this case, we're counting up by ones, so our run will be 1. As we calculate our rise over our run, we will have 2 divided by 1, which means we'll have a rate of change of 2 meters per second. To find our initial value, we just need to find 0 within our independent variable column in order to find out what's next to it. In this case, we have 0, 0 in the table of values, so we know that the line will go through the origin, or it will be a direct variation, so the initial value must therefore be 0. Our independent and dependent variables are easy to find in a table because we know that the independent goes in the first column and the dependent goes in the second. So in this case, we'll use D for distance and T for time. Our equation will be D equals 2T plus 0, or we can just simplify this to D equals 2T. In example 4, we can't find the initial value directly in the table of values because we don't have a value of 0 in our independent column. We could count up, though, in order to find it. We can notice that the run is going up by 1 and the rise is going up by 3. So if we need to start at a number and add 3 to get to 7, we know that this number must be 4. So our initial value will be a cost of $4. In the context of this problem, it means that the cost of a taxi to arrive at the location that you've called it to is probably $4 as a flat fee. We can calculate the rate of change by finding the first differences. We've already determined that the rise is 3 and the run will be 1. This means that as we do rise divided by run, we will have $3 per kilometer. For our independent variable, we will know that it is d for distance because that's the first column in the table, and our dependent variable will be cost. We can use c as our variable for this. Our equation will therefore be c equals 3d plus 4.